For the first question, the invalid method is SSA. If you write SSA backwards, that is a bad word. That is ASS, which is not the word you want to be putting on your test. It's not a valid method of proving triangles congruent. In number 2, we know that we have triangle AED, where AE is congruent to DE. If you draw this triangle without all the stuff going on the inside for a second to make it easier to see, you'll see that what we have is a big isosceles triangle. And in any isosceles triangle, the base angles, the angles opposite the congruent sides, are also congruent to each other. And if we just transfer that into the diagram we have here, that's these two angles. And that's answer choice number 4, angle EAC and angle EDB. They have to be congruent to each other because they are the angles opposite from congruent sides in an isosceles triangle. Moving on to number 3, we have that these sides are parallel to each other, and we have that these angles here are congruent to each other from the givens. Make sure to mark your diagram. It says which method can be used to prove the triangle's congruent. So we have parallel lines cut by a transversal, and if you highlight your parallel lines and your transversal, you'll see your letter Z. In the corners of the letter Z are the congruent alternate interior angles. And we also have a shared side between the two triangles, AC. So AC is congruent to itself by the reflexive property. So what we have here is angle, angle, side, angle, angle, side. Two congruent angles followed by a congruent pair of sides. Moving on to number 4, we're told that EA is the perpendicular bisector of ZT. Perpendicular bisector is a two-part word. The first part, the perpendicular part, means that where it intersects ZT, right angles are created because perpendicular lines form right angles. The second part of the word, the bisector part, means that it's cutting segment ZT into two congruent parts. So those two congruent parts would be ZA and AT. And it says which conclusion cannot be proved. What I want you to realize is that we have two smaller triangles inside this large triangle, and we have a shared side between those two smaller triangles. So right now, what we have is side angle side. So we can actually say that these two small triangles are congruent to each other. So through CPCTC, we can get more information. For example, we can say angle Z is congruent to angle T because they're corresponding angles of the congruent triangles. That's CPCTC. So answer choice 4 is not correct because we can prove that. We just did. Answer choice 3 is also not correct because a median of a triangle connects a midpoint to the opposite vertex. And in triangle ZET, since we know that this is being split in half, A is the midpoint of the side, and it is connecting from a midpoint to the opposite vertex. So that definitely is a median. And since we said that the two smaller triangles were congruent, we can also CPCTC these two angles here. So guess what? If these angles are congruent, then yeah, this whole angle is being split into two congruent parts. So we do have an angle bisector here. So that's not true. That leaves us with answer choice 2. We don't know anything about the relationship between these two sides and this one over here. Through CPCTC, we can say that these two sides are congruent to each other. That would make it an isosceles triangle, but we don't know anything about the relationship between these two sides and this side over here. We don't know if they are the same or not, so we can't assume that they are. So we cannot say it's equilateral from our information here, and what we can conclude with valid conclusions is that it's isosceles, not that it's equilateral. Okay, so here we're given some information and we want to know which one is needed for SAS. So let's try them out. Answer choice 1, GE and LD. That's not SAS, that's ASS. Or if you read it backwards, SSA, which is the same thing. Invalid. Goodbye. Next one. AG. OL. Side angle side. The other two answers couldn't have been it anyway because that would have given you information about two pairs of angles, but side angle side only has one pair of angles. So we did need one of the side choices. Okay, number 6. We're told that RS and TV bisect each other at point X. Since they bisect each other, they're both getting split equally in half. So that means TV is getting split equally and RX is being split equally. Make sure you mark your diagram correctly. We also have congruent vertical angles. So now we have the triangles are congruent by SAS. I'm going to stop here and write this up in the proof so far. Let me quickly write my given information. And after my given information, I need to make sure to put anything that I mark in the diagram into the proof. So that includes the fact that TX is congruent to XV and that RX is congruent to XS. And that was because we had a bisector. A bisector splits a line segment into congruent parts. And now I need to make sure to mention my vertical angles. So that's angle TXR and angle SXV. Make sure to name them with 3-letter names. Intersecting lines form congruent vertical angles. Please write out the word vertical angle. I'm doing shorthand because I'm running out of space here. We do need the intersecting lines part. That's how we know we have vertical angles. They're formed from intersecting lines. And now we can say that the triangle, so triangle TRX, is congruent to triangle VSX, and that is by side angle side. And now what we can say is that angle T and angle V are congruent, and that's by CPCTC because they're corresponding angles of congruent triangles. And now we can end our proof. We can say that TR is parallel to SV because what we just showed is that these two red angles are congruent, and those two red angles are alternate interior angles. And if we show that alternate interior angles are congruent, that proves lines parallel. CPCTC doesn't prove lines parallel, by the way. It proves sides or angles of congruent triangles are also congruent. Nothing about parallel lines. If alternate interior angles are congruent, lines are parallel. Okay, next one. And this one, most of the stuff was given to you already. We have LA congruent to DN. We have CA congruent to CN. And we have angle DAC, side DAC, line segment DAC, perpendicular to line segment LCN. If they're perpendicular to each other, it means they form 90-degree angles. So I'm going to also put that in. And I'm going to stop because we already have enough information. What we have is HL. We have right triangles, congruent hypotenuses, and congruent legs. This is not SAS because the angle is not directly in between the two sides. In fact, if we just go around the triangle, this would be SSA. But since we have right triangles, it's a special case of SSA. It is HL because we're working with right triangles here. And when you have right triangles with congruent hypotenuses, and a pair of congruent legs, that is HL. So let's write up our. Just to save myself some space here, I'm not going to write the givens, but you need to get credit on the test or on the Regents exam. And in fact, both our hypotenuse and our leg are coming from the givens here, so they are super important. Next, I'm going to put the right angles because they're in the diagram, but they're not in your proof. So I'm going to put angle DCN and angle CCL are right angles. And my reason is perpendicular lines form right angles. And since I'm using HL, I don't need to state that they're congruent to each other because I'm not using it as an A in like ASA or SAS. I'm not using it as a congruent angle pair. What I need for HL specifically is to have right triangles. Because if you don't have right triangles, you don't even have hypotenuses or legs, and you can't use HL. So what I actually need to state is that triangle DCN and triangle DCL are right triangles. And you can just say a triangle with a right angle is a right triangle. And then finally, now I have all the information I need to prove that triangle LAC is congruent to triangle DNC, and that is due to H. Okay, in the next one, it says the vertex angles E, so the base angles should be C and M. CE is 3x plus 10. ME is 5x minus 14. And CM is 2x minus 6. Since this is an isosceles triangle, we know that the sides opposite the congruent angles are congruent as well. So I get an equation that says 3x plus 10 is equal to 5x minus 14. Let's take a second and solve our equation. I'm going to subtract 3x from both sides, and over here I get 2x. I'm going to add 14 to both sides, that's 24, so x is equal to 12. And that's all it was looking for, just your x value. Rosa and Liza are marking their diagram based on given information. Rosa made a mistake in her congruent statement. So this is her congruent statement where it says something is congruent to something else. So her method is not the error. It's her congruent statement. So it's the order of her letters. If you redraw this triangle over here so it's facing the same way as XYZ, notice how this should be R, this is S, and this is T. So now we can see X should match up to R, but that's not here in her statement. It's not. She has X matching up to T. And also Z should match up to T. She doesn't have that. She has Z matching up to R. So these letters are a mess here. So for explaining the error, you can say the corresponding parts are not in order. I did take it if you said the letters were incorrect. And we can fix it. Triangle XYZ congruent. If I went XYZ, I'm going to go the same way, RST. And that's part one. Part two is to write two additional congruent statements for corresponding parts. That could either be sides or angles. So I'll just say angle X is congruent to angle R. Those are corresponding angles. And I'll do a side. I'll say side XY is congruent to side RS. And you don't have to justify it, but it's by CPCTC because the triangles are congruent by HL. So then we can CPCTC the other corresponding parts. So that's the reason, but we don't have to even put a reason. Okay, moving along. Let me take a second and plot this. Okay, so I'm going to use slope formula, which is y2 minus y1 over x2 minus x1. And if I can find opposite reciprocal slopes, that means I have perpendicular lines which form right angles, which will prove that we have a right triangle. So I'm going to start with RS and ST because those look like they're going to form the right angle. And if I need to do RT, I'll do that after, but hopefully RS and ST is enough to see those opposite reciprocal slopes. So for RS, this is the slope of RS. The y values are -1 and 7. X values are 3 and -1. So we have -8 over 4. In simplest form, that's -1/2. And then I'm going to do the slope of ST. The slope of ST, if we subtract the y values, it's 2 minus -1. Subtract the x values, 9 minus 3. That's 3 over 6. Oops. My bad. I can't do math today. This is why I should be using a calculator. It's -2. -8 divided by 4 is -2. You can put that in a calculator. So that's -2 over 1. And 3 over 6 reduces to 1/2. So we do have opposite reciprocal slopes. So we do have perpendicular lines, which means we have a right angle, which means we have a right triangle. Since RS and ST have opposite reciprocal slopes, they are perpendicular and form a right angle. So triangle RST is a right triangle. Okay, so for this one, the statements and reasons were all given. There's multiple correct ways that you can write this, but I'm just going to give one way. So of course, you have to start off with at least some of the givens. So let's put our given information in, and that's right over here. So that's this one. So that's DA perpendicular to AB, CB perpendicular to BA, and angle CAB congruent to angle DBA. Let me just mark the diagram. So these are perpendicular, so they form a right angle. And this is angle CAB, and this is angle DBA. Okay, and our goal is to prove angle D congruent to angle C. A lot of people are forgetting their strategies for working with overlapping triangles. You can color code, and you can also draw them separately to make it easier to see what's going on in each specific triangle. So we do need to focus on these overlapping triangles because those are the triangles that contain the angles that we're interested in, angle D and angle C. Let me put the right angles. Let me put the other angles from the givens. So already we have a lot of information about the two triangles. We do also have a shared side between them. So that's going to need to get in my proof as well. First, let me start with the right angles so I don't forget them. So let me mention that they are right angles. So angle DAB and angle CBA are right angles. And this is given. And this is perpendicular lines form right angles. And then if we're using it as a congruent angle pair, because we do have ASA here, so we do need to say that these angles are congruent and these angles are congruent. So we do need to state that they're congruent to each other. and that's because all right angles are congruent. And then we do need to put that shared side AB. Okay. So now we have enough information to prove the two triangles congruent by ASA. And after you prove triangles congruent, you can use CPCTC to get information about other sides or angles in those two triangles, like angle D and angle C. So now we can CPCTC angle D congruent to angle C because we already proved the overlapping triangles congruent to each other. Okay, last one, the fill in the blank proof, and then I am going to just briefly go through the extra credit as well. That is part of the test corrections assignment. So let me just mark the diagram with the givens so I can see what's going on here. A lot of people were not doing that. So we have angle ABE congruent to angle CBE. So that's right here. And I marked it in the diagram. And we have angle ADE congruent to angle CDE. And we're also told in step 2 that BD is congruent to itself. And I know that anytime anything is congruent to itself, that is the reflexive property. Next, they tell us that angle BDA, so that's this angle over here, and angle ADE are supplementary. And then they tell me that angle BDC, this one over here, and the one right next to it are supplementary. So if these two angles are both supplementary, the congruent angles, let's say these two angles are 80. Well, this one would have to be 100 to make 180 with this one. And this one would also have to be 100 because these angles are the same. So if these two angles are congruent, the angles supplementary to them, the supplements of these angles, also have to be congruent because there's only one value they could be to make the 180 with the number that's already there. So this angle and this angle have to be congruent to each other. Angle BDA and angle BDC have to be congruent to each other because they're both supplementary to congruent angles ADA, E, and CDE, the two congruent green angles. That's supplements of congruent angles are congruent. If angles are supplementary to congruent angles, they need to be congruent as well. And now, in our two triangles that we're focusing on, which are these small ones over here, we have ASA, and then we can use CPCTC to get more information, such as the fact that AD is congruent to CD, or that AB is congruent to CB. And actually, there should have been one more step of the proof. It should have been to prove that this angle is congruent to this angle. And that would be by base angle theorem because if two sides of a triangle are congruent, the angles opposite those sides should be congruent as well, right? And triangle ADC here is an isosceles triangle. Okay, moving along, but that wasn't part of the question. Okay, this was a long one. So this one, we need to prove that AB is congruent to CD. So a lot of good ideas here. First, they tell us that FG is congruent to GE, that's marked. And angle ABG is congruent to angle DCG, that's marked as well. And angle F is congruent to angle E. We need to prove that AB is congruent to CD. First off, I'm noticing that these two angles are supplementary, and these two angles are supplementary as well. And if these two angles are supplementary to congruent angles, just like we saw in the last test question, that means these need to be congruent. That supplements of congruent angles are congruent. I'm going to start writing this up so we don't forget it. So this is where we're up to right now in the proof. And yes, you do need to state that these two angles are supplementary and that these two angles are supplementary before you can then use supplements of congruent angles are congruent. Moving along, that gives me an angle in the overlapping triangles, and I'll separate them in a second. But before I separate them for you, I just want you to see that now, based on what we proved in step 3 about these two angles, that we now know that triangle GBC has two congruent angles. And if a triangle has two congruent angles, it's got two congruent sides opposite from those congruent angles. That's converse of the base angle theorem. If two angles of a triangle are congruent, then the sides opposite are congruent. And now we have the pieces of the side of the big overlapping triangle and the pieces of the side of this big overlapping triangle. And if that's a little bit hard to see, I'm just going to really quickly color code and separate the two overlapping triangles so we can see a little bit clearer what we have in them. So that's FAC and that's EDB. So right now we have the two black angles. I'll just mark them the same way as I marked them in the original diagram. And that's it. Oh, I lied. We also have these angles at the top that was given to us. And now we have the pieces of this whole side FC and the pieces of this whole side EB. So if we have congruent pieces, if we add them together, we can get the whole sides that we need. And if we add the pieces together and we get the whole sides, then we can prove those triangles congruent with ASA. So let's do our addition. So that's FG plus GC. And that gives us the whole side of the yellow triangle FC. And then here we're adding EG and GB. And that gives us the whole side of the red triangle, EB. So where we added the segments together, that is the addition postulate. And then we said this plus this is that, this plus this is that. So we're replacing the addition with what it actually is. And that's substitution. So now, as we just said, we can say that the two triangles, the overlapping big ones, triangle FAC and triangle EDB, are congruent. And that is by ASA, clear to see once you separate the triangles. And then through CPCTC, we can say that these sides, AC and BD, are congruent. And that's going to help us because our goal is to get information about AB and CD. So AC is this whole side over here. BD is this whole side over here. So now we have that the whole sides are congruent. And if we want to get the pieces, we can subtract. AC, take away BC, leaves us over with AB. DB, take away CB, leaves us over with just CD. So let's write out the subtraction. Before we can do the subtraction, we do need to say that BC is congruent to itself by the reflexive property because we are going to be subtracting that from both longer segments to arrive at our shorter segments. Let me get a little bit more space over here. I don't want it to completely go off the screen. Okay, so we have AC minus BC, and that leaves us over with AB, which is the segment that we want. And then we have DB, the long segment, take away BC, and that leaves us over with CD, which is the segment that we want. So where we're actually subtracting, that is subtraction postulate. And then this minus this is that, this minus this is that. So that would be substitution. So this was a long proof. This was 11 steps.